What is a tsunami, you may be asking after that explosion. Tsunami is actually Japanese for harbor wave. Harbor wave does not accurately describe tsunamis because they start out much further in the ocean. Tsunamis can come from a variety of sources. Nukes, like the one in the intro, meteors, volcanic eruptions, glaciers, and landslides, and most commonly earthquakes. While earthquakes are the most common type of tsunami, the largest tsunami wave ever recorded was caused from a glacier falling in Alaska. It produced a tsunami wave about 1,700 feet high. What's even crazier is that a small fishing boat actually rode over the wave and survived. The true definition of tsunami is not a harbor wave. It is, however, a bunch of energy moving through the water. To further understand tsunamis, you have to look at the 2004 Indian Ocean earthquake tsunami. Energy cannot be created nor destroyed, and the way that the energy travels from the earthquake through the water is longitudinal. The force first goes up due to the initial push from the earthquake, then quickly comes down due to gravity, and then it ends up going out due to the back and forth balance between the two. The energy released during the earthquake was 1.1 times 10 to the 17th joules. To make that number tangible, here is a baby carrot being thrown at me.
Nice!
Now would be a good time to ask if that even proved anything. Well, it did. We can tell from the video that the carrot is 5 meters away from me and gets to me in 0.5 seconds, making it go 10 meters per second. Plugging that into the equation, kinetic energy equals 1/2 mass velocity squared. We can go through the equation and figure out that it actually has 520 joules when it leaves the hand. Using the same equation for kinetic energy and having the total kinetic energy be that of the total energy released during the tsunami, we can find the mass to be 2 times 10 to the 15th grams. Divide that by 10.4 grams and you find that it'd be 2.1 times 10 to the 14th carats. Going even further, you take the total number of carats that it would take thrown at 10 meters per second to equate that of the tsunami and divide it by the amount of carats produced per year in kilograms, and you find that it would take almost 60 years to get all of the carats necessary. Tsunamis are extremely destructive, not only because they have a lot of energy that goes through them, but also because they're sneakier than a fox robbing a bank. At the epicenter, the tsunami wave is only millimeters high, meaning it has a very small amplitude, while having wavelengths miles long and a very high wave speed. The 2004 Indian Ocean tsunami traveled at 134 meters per second, or 304 miles per hour at its epicenter. Most of the tsunamis out at sea do not produce a noticeable wave due to its low amplitude. However, when it reaches the shore, a process known as wave shoaling occurs. Wave shoaling is the process where wavelength gets shorter along the shore while keeping a consistent frequency and slower wave speed, making much higher waves in amplitude. This basically means that tsunami waves start out really small and fast and end up really big and slow. Due to Newton's first law of objects in motion staying in motion, and the fact that there is no net force acting outside of it, means that all of the energy is transferred into one ground-smacking wave. Tsunamis are big, beautiful waves. Tsunamis start out really small, but then end up getting really big. And then they end up destroying everything in front of them.
which really makes them okay in my book. Thanks for watching.